Okay, let's jump right into this deep dive. We've got our hands on an advanced look at something interesting, a new textbook coming out from the Bald and Bonkers Network Academy.
That's right, an exploration on extraterrestrial life.
Exactly. And our mission today is to dive deep into this specific source material. You, our listener, shared it with us because, well, you're curious about life beyond Earth, right?
And you want to know if this book is a good starting point, a useful foundation.
Yeah. Are we alone? It's got to be one of the oldest, biggest
Wow.
questions humans have ever asked.
Definitely.
And this textbook, this academy material, it aims to lay out the scientific evidence and, reasoned speculation.
From things like UAPs, the chemistry of life, all the way to distant planets and those big paradoxes.
Right. So we're kind of guides through this book today.
Exactly. We're not here promising definitive answers on aliens, and frankly, neither is the book.
Good point.
It's really about exploring the landscape, the evidence, the questions that come up when you look at this seriously. Will help pull out the key stuff from this material.
Okay, so where does this book kick things off? It talks about something we've probably all noticed, this shift in how people talk about UAPs.
Unidentified aerial phenomena. Used to be UFOs.
Right. For so long, that whole topic was kind of pushed to the fringes.
Yeah, absolutely. Dismissed, ridiculed.
Hmm.
You know the drill. Blurry photos, weird claims.
And the lack of transparency from official places didn't help. It just fueled that perception.
But what's interesting is how this material frames that change. It wasn't just like one big reveal.
No.
It's more subtle. It points to evolving attitudes in society and maybe more importantly, a growing recognition, even in official circles, that maybe we don't understand everything we see.
And the book mentions those declassified documents.
Yeah, that gradual drip feed showing that actually governments were taking some sightings more seriously behind the scenes than maybe we thought.
That Pentagon preliminary assessment in 2021, that felt like a real moment, didn't it? The textbook flags that one.
It does. Highlights how it acknowledged UAPs that, well, defied easy explanation. Called for more digging.
That felt different, that official stamp.
It absolutely did. And that kind of official shift seems to mirror what's happening in public perception, too.
The stigma is fading a bit.
Seems like it. There's more genuine curiosity, less automatic dismissal. The conversation feels a bit more nuanced, more scientific, maybe.
And this material mentions credible sources like military pilots coming forward more.
Right, trained observers. Plus, technology. Everyone's got a camera now.
High-def cameras in our pockets and drones everywhere.
Makes documenting weird stuff easier. And it puts pressure on institutions to be, well, more open about it.
So this first part of the book really sets the scene.
Exactly. It's basically saying the timing is right for this kind of serious exploration because the whole conversation around the unknown is already changing. We're maybe moving towards being more open to these big questions.
Okay, so fundamental question time. The book tackles this next. If we're looking for life, what? What are we looking for?
Yeah, that's key. And it grounds us first in life here on Earth.
Starts with the basics. Talks about the workhorses of biology. CHNOPS.
Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur.
Right. And it really highlights carbon. 4 dawns makes all those complex molecules.
Chains, rings, the architecture of life. And the book stresses water, too. Hugely important.
Universal solvent.
Exactly. Its properties, those hydrogen bonds, essential for moving stuff around, for reactions, for letting molecules fold correctly. Life as we know it really depends on this chemistry in water.
And it's where it gets really interesting, right? The book cautions against being too Earth-focused.
Yeah, the Earth-centric bias. What if life uses different building blocks? It explores alternative biochemistries.
Like silicon.
Yes.
It's right below carbon on the periodic table.
It is. And the book looks at it, but it also clearly lays out the chemical hurdles.
Hurdles like what?
Well, for one, silicon bonds are weaker than carbon-carbon. Makes it harder to form those long, stable chains you need for complex molecules like protein. And maybe even more critical, silicon loves oxygen. They form incredibly strong bonds, leading to silicates, rocks, basically.
So insoluble stuff. Hard to move nutrients around if everything turns to sand.
Pretty much. Imagine trying to run a metabolism like that. The book mentions other ideas, too, like phosphorus or arsenic.
Didn't that arsenic life thing get debunked? The GFAJ1 bacterium?
Yeah, the book references that. The initial excitement didn't quite hold up. So the takeaway isn't that alternative life is impossible.
But the carbon and water seem the most plausible based on what we know now.
Exactly. While keeping an open mind because, The universe is huge.
And speaking of possibilities, the book gets into life's extremes on Earth, extremophiles.
Yes, studying these guys is so important. Organisms thriving in insane conditions, boiling hot, freezing cold, crushing pressure, high radiation.
Places we used to think were totally dead zones.
Right. And this material uses them to really push back on our narrow definition of a habitable zone. Life is tougher, more adaptable than we maybe thought.
Like those deep-sea vent communities. Living off chemicals, no sunlight needed.
Precisely. Chemosynthesis. And the book connects this directly to places like Europa and Enceladus.
Jupiter's moon and Saturn's moon, the icy ones with oceans underneath.
Strong evidence for subsurface oceans, yeah. If those oceans have hydrothermal vents like ours.
You could potentially have the energy and chemicals for life without needing sunlight way out there.
Exactly. Extremophiles show us life might pop up in environments we'd otherwise dismiss. It really broadens the search.
Okay, so we have some ideas about what life might need chemically
Yeah.
and that it can survive harsh places. How does the book say we actually look for it?
Well, the search is definitely on. The book covers the main strategies. First up, exoplanets.
Planets around other stars, which are tiny and super far away.
And right next to their blindingly bright stars,
Yeah.
a huge challenge.
But astronomers have gotten pretty clever, haven't they?
Ingenious methods, as the book says, and finding thousands of them, it tells us planets are common, really common, and diverse. That ups the odds for life being out there.
And the book talks about searching for biosignatures, signs of life in their atmospheres.
Yeah, this is a huge, rapidly developing field. It points to telescopes like JWST, the Webb telescope, and future ones.
The extremely large telescopes.
Right. They're designed to be sensitive enough to analyze the light filtering through an exoplanet's atmosphere.
And look for what? Specific gases.
Things like oxygen, methane, water vapor, yeah. Finding them in certain combinations, certain ratios, could indicate biology at work.
Good.
Well, the book is clear about the challenges. You have to distinguish biological signals from just geological or chemical ones. And just technically separating that faint planet light from the overwhelming star glare is incredibly hard.
Makes sense. What about SETI, the classic search for extraterrestrial intelligence? Still mostly listening for radio signals.
Primarily radio, yeah.
Hmm.
The book mentions it's practical for crossing vast distances. It also notes looking for optical signals like powerful laser pulses.
Harder to detect, I imagine.
Much harder. Requires very sensitive, targeted searches. And SETI faces huge hurdles overall. The distances, signal weakness, needing amazing detectors, and the big one, we have no idea how aliens might communicate, or if they'd even try to broadcast signals we could pick up.
Okay, shifting focus closer to home. The book details robotic missions right here in our solar system. Mars gets a lot of attention, obviously.
Of course, decades of missions. Mariner, Viking, those early ones were foundational, even if Viking's life results were inconclusive.
Then the rovers. Spirit, Opportunity. Finding evidence of past water.
Big deal. Then Curiosity found organic molecules, confirmed habitable environments in the past, and now Perseverance.
Collecting samples for potential return to Earth. It's huge.
Game-changing if it happens. And Ingenuity, the little helicopter, proved flight is possible on Mars. Opens up new exploration ideas.
What about those icy moons we mentioned? Europa and Enceladus. The book highlights them too.
Absolute prime targets, according to this material. Europa orbiting Jupiter. The evidence for that huge subsurface ocean is really compelling.
How do we know?
Surface features look like they're shaped by liquid below, and its interaction with Jupiter's magnetic field, it acts like a conductor, which points to a salty ocean under the ice. The book mentions the Europa Clipper mission is going to study this. Look for plumes, use radar.
Plumes. Like geysers.
Yeah, which brings us to Enceladus, Saturn's moon. Maybe even more exciting right now because Cassini saw geysers erupting water vapor and organic molecules from cracks in the ice.
Wow. So we could sample its ocean without drilling.
That's the incredible opportunity the book points out. And it raises the possibility of chemosynthesis happening down there, like Earth's vents, powering life.
Any other spots?
Titan gets a mention too, Saturn's biggest moon. Unique place lakes of liquid methane and ethane, thick atmosphere, could host really different life, maybe not even water-based. Needs different kinds of missions, maybe drones or balloons, the book suggests.
So, amazing potential targets nearby. But sending missions, that's going to be tough.
Oh, hugely challenging. And the book is realistic. Distance means communication delays, minutes, even hours. Power is a constant issue far from the sun. RQG's nuclear power.
Instruments need to be tiny, tough, low power.
Exactly. And the big engineering problems drilling through miles of ice, building a sub for an alien ocean. We need continuous innovation, the book stresses that.
Okay, so summing up, universe is vast, planets are everywhere, life here is tough. Statistically, it feels like life should be common, right? Maybe even smart life.
That feeling leads straight to the Drake equation, which this textbook dives into.
Right, the equation to estimate communicating civilizations.
Well, the book is careful. It's less a precise calculation, more a framework. Its real value is showing us all the different factors involved, and crucially, how little we actually know about most of them. It organizes our ignorance, you could say.
Huh. Okay, so walk us through some factors it mentions.
Sure. It starts with, the rate stars form in our galaxy. That varies. Then the fraction of stars with planets we now know that's high, thanks to Kepler-Tate-S.
So that number's gone up.
Definitely. But there are still biases in detection. Then, the number of planets per star that could support life, the habitable ones. That connects right back to extremophiles and subsurface oceans. Maybe our definition is too narrow.
Makes sense. Then it gets more speculative.
A lot more. The fraction where life actually arises. We only have Earth as an example. Huge question mark. Needs a biogenesis research. Then, the fraction of life-bearing planets where intelligence evolves.
Another giant unknown. What even is intelligence beyond our model?
Exactly. Then, the fraction that develops technology we could detect, like radio, depends on society, energy, motivation. Do they want to broadcast? And maybe the biggest unknown, L, the lifetime of such a civilization.
How long do they stick around before something happens?
Right. Self-destruction, resources run out, cosmic disasters. Estimates based on the Drake equation are all over the place because of these unknowns, from just us to billions.
But the book says its value is driving research, asking the right questions for each factor.
Precisely. And it sets up the next big puzzle, the Fermi paradox.
If the odds suggest life should be common, where is everybody?
The great silence. The conspicuous absence, as the book puts it.
And the textbook goes through possible answers. Solutions to the paradox.
It does. It mentions the great filter idea, some incredibly hard step that stops life from becoming interstellar. Maybe it's behind us, life starting is super rare, or maybe it's ahead of us.
Like civilizations tend to wipe themselves out.
That's one future filter possibility, but the book notes this is inherently untestable, especially future filters. We just don't know.
What other ideas does it cover?
Difficulty of travel and communication. Just the vast distances, the energy needed. Even Siot makes space travel incredibly costly. Signal delays are huge. Maybe signals are weak, or maybe they use methods we can't even imagine detecting.
Like psychic space whales.
Well, maybe not that specific, but yeah, communication modes beyond radio or light. Then there's the zoo hypothesis.
They're watching us but hiding.
That's the idea. But the book calls it pure speculation. No evidence, no strong reason why all advanced life would do that. It also suggests maybe our definition of life or intelligence is just too limited. We might not recognize it if we saw it.
And the timing thing. Civilizations missing each other.
Yeah. Cosmic timescales are vast. Civilizations might rise and fall in the blink of a cosmic eye, never overlapping. So no single easy answer presented in the book.
It feels like the book treats the silence itself as meaningful.
That's a key takeaway. The silence isn't necessarily proof of absence. It tells us about our limits, our tech, our understanding, our assumptions. It forces us to question everything. It's a rich puzzle.
Okay, the book then shifts gears a bit, moving beyond pure science to things like UAP reports again, and even alien abduction accounts. Focuses more on the human experience.
That's a crucial distinction this material makes, yeah. When discussing abduction reports, it's not trying to verify if the events literally happened. It's analyzing the reports themselves.
Looking for patterns.
Exactly. Consistent themes that pop up, paralysis, medical exams, seeing advanced tech. The focus shifts to why people report these experiences.
So examining the narrative, the psychology.
Right. The book discusses psychological factors, suggestibility, cultural influence from sci-fi, maybe mass hysteria sometimes, societal anxieties about the unknown.
Does it mention specific phenomena?
It brings up sleep paralysis and hypnagogic hallucinations, those vivid, sometimes scary, dreamlike states when falling asleep or waking up, where you might feel paralyzed, see things. The book suggests these could potentially explain some core elements of the abduction experience.
So why study these reports if they might not be literal alien encounters.
The argument presented is that they tell us a lot about the human condition, perception, belief, fear, maybe a deep longing for connection with something bigger. It becomes a subject for psychology, sociology, anthropology, understanding the human psyche and our cultural stories.
Got it. Okay, final big area the book tackles. What if? What if we do find life, especially intelligent life? The implications.
Oh, yeah. The book stresses this would be world-changing. Not just science, but society, philosophy, religion, everything. It outlines potential upsides and downsides.
Benefits like?
Medicine, potentially. Discovering totally different biology could revolutionize how we understand life, treat diseases, maybe find new ways to resist radiation or regenerate tissue. Technology, too, could an advanced civilization give us insights into energy, materials, travel, communication, maybe new physics.
Sounds great. But there have to be risks.
The book is very clear on the risks. Conflict is one misunderstanding, perceived threat, resource competition, or disease. Alien microbes we have no defense against, or us accidentally wiping them out with ours.
Huge ethical questions there.
Massive. And the book says we need to think about them now. How do we even try to communicate? What message do we send? How do we handle vastly different values? Resource sharing, planetary protection, not contaminating them, not getting contaminated. It calls for ethical frameworks, international cooperation, proactive planning.
And public preparation is key.
Absolutely. The book emphasizes education, astrobiology, media literacy, and clear, transparent communication strategies if discovery happens. Avoid panic, manage expectations, speak with one voice, basically.
Wow. Okay, so we've really dug deep into this bald and bonkers Network Academy textbook.
Yeah.
Covered the science, the big questions, the human side.
Yeah, this source definitely gives you a solid grounding. Covers the renewed buzz around UAPs, the chemistry basics, extremophiles pushing boundaries, the search methods for exoplanets, and our own solar system neighbors.
Grapples with the Drake equation's uncertainties, the Fermi paradox silence.
Right, and it doesn't shy away from the human reports or the huge implications, scientific, social, ethical, if we ever make contact.
It paints a picture of a vast universe, full of potential, maybe teeming with life in ways we can't even guess yet. And our tools for looking are getting better all the time.
But it also makes clear the immense challenges, defining life, the distances, the paradoxes. This book doesn't pretend to have the final answers.
No, but it gives you a really comprehensive map of the territory, doesn't it? Shows you what we know, what we don't, and what we're trying to figure out.
And when you really think about all those unknowns we discussed, the Drake factors, the Fermi solutions, the possibility that life or intelligence could be fundamentally alien to our concepts.
It really underscores how much we don't know.
It really does. You know, considering we're still finding surprises about life's limits right here on Earth, still grappling with the nature of consciousness, still probing the fundamentals of physics, maybe the biggest mystery isn't why we haven't found ET yet. Maybe it's just how incredibly mind-bogglingly different life could be from anything we can possibly imagine right now.
That is definitely a thought to sit with. This deep dive, using this bald and bonkers textbook as our guide, really shows the search for extraterrestrial life is so much more than just science. It pushes boundaries, challenges us, makes us think about our place in it all. Understanding this landscape, even without the final chapter written, feels incredibly worthwhile.